Let's understand the code of the button controlling the LED. Let's again remember that we are using pin number 2 for the button and pin number 9 for the LED. Let's also remember that a push button is a digital input. Why is it digital? Because it has only two states. It can be on or off. It doesn't give a range of values, so it's a digital input. The LED in this example is used also as a digital output, that it can be only turned on or off. Now here before we said that we have always the void setup, that we here declare our inputs and outputs, and we have the loop. Before the setup, we want to declare every pin as a constant or a variable. Instead of every time typing number 2 for this pin and number 9 for this pin, we can give it a name, we can give it a constant. Instead of every time saying 2, we will name it as button pin because the button is connected to it. And number 9 will be the LED pin. How do we type that in the code? Const means constant, int, integer, button pin. Now this is optional. You can call it button or push button or button pin or push button pin. It's the name you're using. Now which pin to put for that name? We need equals, then 2, and of course the semicolon. Now this means instead of every time typing 2, now the name of it is button pin, means the pin of the push button. Now the same we will do for the LED. Const int LED pin. Which one is the LED pin? It's number 9. Now the status of the push button, that will be either 0 or 1, means not pressed or pressed. This will call it the button state. The button state. It's an integer. We call it button state. For now, initially, give it 0. Of course, semicolon. Now the void setup. What do we need in the void setup? We need to declare that the LED pin is an output. The button pin is an input. Which statement gives us that option? It's the pin mode. You learned it before. Pin mode with capital M. Pin mode bracket LED pin. If you type here 9, that will be correct. But here we said that 9 will be the LED pin. So it's enough here to write LED pin. If you name it here LED, here you have to type LED. Or you keep it here 9. Pin mode 9 output, because we are using it as an output. Pin mode 2, that is the button pin 2 input. So here we prepare that the LED pin is an output, that is number 9. The button pin is an input, that is number 2. Now we need, in the void loop, we need to read, we need to take the status of the button. Which statement helps us in that? It's digital read, means read the digital pin. Digital read, this is how we have to type it with capital R. Digital read, read which pin we want to read, pin number 2, that we call it the button pin. So digital read button pin, and put it where? In the variable button state that we defined it here. So in button state, put equals, put what? Digital read, the status of the button. This one you have to memorize it very well, how to type it and how to use it. It's to read an input status, a digital input status. Now we have if condition. You know if else. If the button state equals 2 times we have to repeat it, high, This means if the button state, if here you are reading the button as high, means the push button is pressed. This high means my button is pressed, is passing the 5 volt here. So if the button state is high, what to do if this is pressed? We need the LED to glow. Okay, then digital right, LED pin high. This one we learned it before. It's to glow the LED, to give high, to give 5 volt signal to the LED. Now we have digital read to check the button. If the button is pressed, glow the LED. What if it's not pressed? Else means otherwise. Else we need to keep the LED off. Digital right, LED pin low. So let's now summarize it, all of it together. Pin number 2 will be button pin. Pin number 9 is LED pin. We have the button state, the push button status. Initially it's 0. The LED pin, declare it as output. The button pin, input. Read the push button, read the status of the push button, digital read, and put it in button state. If the push button is pressed, is high, glow the LED. Otherwise, turn off the LED. You can in Tinkercad create this circuit, type this code. The comments are to make you understand, and simulate it and test it.